read that to you to end the evening. Let me go to this last question over here. Yes?
What are the uses of the...
Wait, how old are you?
Oh, I'm 10, almost about to turn 11.
Okay, 10, almost about to turn 11. Okay, cool. Well, thanks for coming tonight. Thanks for coming. It's late night, past my bedtime. I don't know if that's your bedtime. But okay, so what's up?
What are the uses of the elements, like the ones at the end of, like, the bottom of the table of elements, after the stuff like uranium, like berkelium or unpentium?
Yeah.
What are those uses?
Yeah, okay.
I never thought of those.
Yeah, so here's what's cool. There's some elements we don't quite know what to do with yet. They're just kind of sitting there, waiting. But I'll give you an example. We discovered the element that became named americium, named after America, okay? That's heavier than uranium. I forgot which number, was it 96 or something? 95. Pack of chemists will not be denied the truth of the periodic table. Thank you, I was close. Americium, it turns out, became the active ingredient in smoke detectors. When I was your age, we didn't have smoke detectors. You know what we had? We had the next best thing, flame-proof pajamas. Okay? So what that meant was, if fire was in my room, and I haven't figured it out yet, and it tried to ignite my pajamas, I would not burst into flames from that. Okay. That's how life used to be before americium. Right now we have smoke detectors. Some people use them as indicators when their food is ready.
That's why we don't have any.
Timers for what's in your oven. But the point is, smoke detectors will alert you way before you have flames licking at your pajamas, ready to ignite you into flames, okay? So that's an example of a very heavy element doesn't even exist in the universe, that now sits in basically every single room in civilized society. So that's an example. Now, if you look at that video series, The Inexplicable Universe, I talk about something called, chemists help me here, this with the valley of something. Thank you. If you go to very heavy, many of these heavy elements, they're all these protons packed together, and they're unstable, and they want to bust out some neutrons, and it is a very turbulent place. All those elements are radioactive, okay, which means they're unstable. All physics that we know tells us that beyond a certain high mass element, there's something that we're calling an
island of stability.
Thank you. An island of stability, where supermassive elements will hang together and exist for longer than just a few fractions of a second. Heavy elements that are stable. I am drooling at the mouth at what new applications we might find from these elements. A whole new place on the periodic table. A place that the universe doesn't even know about. And we get there. So, I don't know, but we make some new materials, I don't know. That's what research is all about. Einstein said research is what I'm doing when I don't know what I'm doing. So, when you grow up, maybe you'll find those elements sitting on the shelf doing nothing. And you'll find some really cool application for it. I'll be watching you. Now let me end with the answer, if I may. Sorry, where was it? Oh, not here, wait, that's not it. So the question was, you were trying to slip in a question while I'm finding my reply here.
Tell us your favorite science joke.
My favorite science joke. Okay, you ready? Favorite science joke. You know about the Higgs boson, right? The Higgs boson, its field grants mass to particles. Right? That's, if you want to be a particle, that's going to be the Higgs boson. In fact, it's been called the God particle, because of the power it has over all the other particles. And it was discovered at CERN last year, and the Nobel Prize was given for it. Very cool. So, there's a friend of mine, his name is Brian Mallow, whose Twitter handle is Science Comedian. Yes, there are such people in the world. So he invented this joke, and I think it's short and awesome. Okay, here it is. A Higgs boson walks into a church. I tested this on a Jesuit priest, he said it was cool. So here it is. A Higgs boson walks into a church. The priest says, sorry, we don't allow Higgs bosons in church. The Higgs boson said, but without me, you can't have mass. All right.
Tell me that tomorrow.
It's titled, If I Were President. The New York Times asked me during one of the impasses in Congress, and they thought they would go find people who were not traditionally thought of as politicians and see if they had a solution that could help out the world. And so if you were president, what would you do? So this was my reply that they printed. The question, if I were president, I would do, implies that if you swap out one leader, put in another, then all will be well with America. As though our leaders are the cause of all ailments. That must be why we created a tradition of rampant attacks on our politicians. Are they too conservative for you? Too liberal? Too religious? Too atheist? Too gay? Too anti-gay? Too rich? Too dumb? Too smart? Too ethnic? Too philanderous? Curious behavior, given that we elect 88% of Congress every 2 years. A second tradition in progress is the expectation that everyone else in our culturally pluralistic land should hold exactly your own outlook on all issues. When you're scientifically literate, the world looks different to you. It's a particular way of questioning what you see and hear. When empowered by the state of mind, objective realities matter. These are the truths of the world that exist outside of whatever your belief system tells you. One objective reality is that our government doesn't work. Not because we have dysfunctional politicians, but because we have dysfunctional voters. As a scientist and educator, my goal then is not to become president and lead a dysfunctional electorate, but instead to enlighten the electorate so that they might choose the right leaders in the first place. Detroit, thank you all.